Our goal is to create the most human-like robot possible. This vision drives every team at XPENG Robotics, uniting our efforts in industrial design, mechanical engineering, motion control, and beyond.
We've always wanted our robot to feel familiar. It moves with a quiet kind of grace, soft arms, warm gestures, and hugs. To achieve that, we developed a general-purpose humanoid design framework. It is not just an aesthetic guideline. It is a body logic that keeps the robot balanced, expressive, and coherent across different sizes and use cases. Based on this framework, we created the new generation Iron, a general-purpose bionic humanoid built layer by layer, from a compact skeleton to its muscle-like lattice structures, to the soft outer skin that makes it feel almost human to the touch.
Every part of the human body is really a masterpiece. The way our ligaments, muscles, and bones work together gives us an incredible range of motion. To make our robot as human-like as possible, we carried out a deep biomimetic study based on human anatomy, and then followed it up with solid engineering optimization. When we were developing its movements, we realized just how important the waist degrees of freedom are. Instead of using simple rotational joints, we designed a structure that's more like a real human spine. We also tried adding even more DOF to see if we could boost performance, but of course, that made the control systems more complex. Thanks to all this work, our robot can now do genuinely human-like actions, things like shrugging or hugging, and even simple motions such as nodding, bending, or walking now look much more natural and fluid.
It's actually very similar for robots. They also need highly efficient learning methods to perform at a top level. We have basically rebuilt our reinforcement learning algorithms from scratch, training motion controllers that are extremely robust. Because of that, our robot can keep a smooth, human-like motion even when its muscle structure or skin materials change. The problem was the unique properties of the lattice material made it extremely hard to simulate its dynamic effects efficiently. In simple terms, no one could really tell how the muscles would affect the system's dynamics. To overcome that, we have collected a massive amount of dynamic data and developed our own proprietary algorithms for system identification, specially tailored to the muscle's lattice. Then we use the computational methods to optimize the structure. On top of that, we precisely calibrated the robot's model parameters, which finally made efficient simulation of the lattice structure possible.
With the coordinated cooperation of hardware configuration, software control, and appearance design, with flexible waist twisting and natural shoulder shrugging, our new generation robot showed an elegant catwalk at the Technology Day. Every step forward of XPENG means that we are getting a little closer to our vision of perfect collaboration between machine intelligence and human wisdom. Looking forward to standing by your side, shaping the next change with your own hands, and growing together.